All right, we're going to tackle problem number 36 here. It says a survey crew taped 2,000 feet along a straight railroad rail on a 5% grade. If this measurement were reduced to a horizontal measurement, the distance in feet would most nearly be one of those four answers. All right, so always just set the problem up. You got two guys in the field here. They're on a railroad track that's straight. It's on a 5% grade. And they are taping. The question kind of reads like they, had just pulled one 2,000 foot tape, which is, obviously not going to really happen. In real life, this would be several 100-foot segments or 200 foot, depending on what kind of tape they had. But we're pulling a chain and being 66-foot segments. But this is make-believe. So in our make-believe world, this is what our triangle looks like. And we do know that they have taped and pulled this long side. That looks upside down if you're thinking about it, because you would obviously be taping from standing on top of it. But that is part of the make-believe problem. They would have been standing on that slope. So 2,000 foot, we know that for sure. And 2,000 foot will be on the long side. Alright, just labeling the information we know. We know that this line is on a 5% grade. And that's going to be our 90. So here we go. Alright. How I approach this particular problem is, I know that this 5% grade, this is actually going to be, I can get this angle easily from that. It's every 1% of grade is going to give you 0.57 degrees of angle. And so I'll spare you the math there. It's 2.85, I believe. 0.57, yeah, 2.85. So this angle is going to be equal to 2.85 degrees. Or we can go ahead and calculate this short side, which is easily done by 2,000 times your percent grade, which is 0.05, gives you 100 feet. Okay. So without doing any type of complex math, we have identified two sides and an angle of a right triangle. Well, so we have two angles and two sides. Should be fairly easy from here. You can use your Pythagorean theorem, which is, since this is across from your 90, that's going to be your hypotenuse. So a squared plus b squared is equal to c squared, is what they tell me. So once we plug these numbers in, you have 100 squared plus x squared, which is our unknown, which is the side over here we're solving for. Let's make that x, because I like that variable. And c, which is always your hypotenuse, is 2,000 squared. Okay, so now all we got to do is some basic rearranging. If we want to get rid of that, we just subtract it. It's minus 100 squared. Crossing that out. If we want to get rid of the squared, we're going to take the square root. Okay, and let's see with our math here, handy dandy math calculator, that's going to be 4 million. That's an easy one. Minus squared, it's 10,000. So you're going to end up with 4 It's not gonna be 4 million anymore, huh? 3,900,000. Wow, that's a horrible 990,000. And you just want to get the square root of that, which I cannot do in my head. Clear 3990123, right? Yep, got that right. And square root is going to give us 1,997.498, 997.498. All right, then the other way that you can tackle this issue is you can use, since you got a right triangle, you can use your law of cosines here. Because you have your angle. So cosine is equal to adjacent, which is what you're looking for. It's touching the side that you're looking for is touching the angle. So there's your hypotenuse. All right. Let's pull this up, and we got the cosine of, let's say 2.85, 2.85, and let's change my calculator to okay, there we go, and 2.85 trigonometric function cosine. That is 0.9987. 0.9987 equals x over 2,000. All right, so all we got to do in order to get rid of this is multiply it over times, let's not use that x, that's a bad idea, 2,000, and cross that out, and we are going to get times 2,000 equals, look at there, it's all going to equal 1,997.526. 526. Very similar answer. Well, when we start to round things off, it's going to be the same answer. You're going to round that up to 0.5. You're going to round that down to 0.5. And I believe that was, yep, there it is. Number A, or letter A, 1997.5. Let's see how they tackled that problem. I think it's down here. 36. There we go. So they used Pythagorean theorem. They just used a different technique to square it. They just raise it to 0.5. So got the right answer. Multiple ways of getting that. Probably can see that there's always a little bit of rounding error, especially when you're dealing with angles. So, all right, see you next time.